There's like
so then yeah, you
10 or 20 seconds delay on YouTube.
Yeah, and you can just share that on Twitter and on the main one.
I'll do that.
Oh, I know the problem here. Wait. I have to stop that. All right, cool. Welcome, everybody. Let's do this. So this is the last session of the day. We're going to be looking at something that is close to my heart at the moment. I've been working on this product for a while and some of the team that made it possible are actually here. This is some of the work we're doing at Glasswall, it's the company I work for. And we're going to do a threat model of it. And we're going to talk about some of the challenges that we actually have with doing in a cloud environment and doing in a scalable way. And we walk you through some of the issues that we have and some of the ways to think about this and some of the things we're fixing and how we kind of addressing some of the security controls and mitigations about this application. So first of all, welcome. So we expect you to participate, have mutual respect for each other, challenge each other, challenge me, challenge the presenters, challenge the comments. But again, be very solution focused. So everything here is about openness. We share everything. Actually, we're live streaming to YouTube today, trying it out, see how it works, right? And if you don't want to be identified, just basically put, don't turn your video on, put an A. And then everything we do here is under Creative Commons of open source. So, we try to facilitate everything to be open. And we have a, respect for everybody. Please, be fair with everybody, respect everybody's comments. And if you spot anything, let us know because we take this very seriously. And finally, share your views. There's the hashtag, there's a Slack environment for you to participate and learn, right? So this is basically, we're trying to make this as much of a sharing experience as possible. And we want you guys to learn as much as you can. So, and Matt, is here from the team. I think we actually have a good number of the team here. Matt, you just want to introduce yourself?
Yeah, sure. Matt Covey, I'm the Cloud Development Manager at Glasswall Solutions. Yeah, been overseeing the development of this product for a while now. Interesting to see how it's going to be used now.
So the product that we're going to be looking at, we're doing a threat model and we're going to analyze, is actually a product that we launched recently in our store, which is basically this product where you can actually buy now, which is really cool. You can come buy it for £1 or, and it's about the technology that we have where we rebuild files and we make files safe. And I'll walk you through a little bit how that works. So you understand the flow of everything and how everything fits together. And then we're actually going to look at behind the scenes and then look at some comparisons between, for example, this version and the version that we can run in a dedicated cloud environment. And then that version and the version that you can actually run the SDK in EC2 into a different type of platform, which is all different ways to use. Each one would have its own security concerns and security advantages. But to get you an idea of what it is, I can actually probably show you here. So I put the link for you on the site to this. There's two websites you can hit. There's two actually servers that you can hit. That one with more juice than the other. So one will have support multiple files and bigger file types. And this is actually running off EC2, which is another cool thing, even from a security point of view. So we got to the point where we can just spin up new instances on the fly, fully self-contained, using Docker Compose. And kind of the way this works, and what I really want you to do here, and please, start opening up issues as we discover them. Raise your hand or put them on the chat. What I want to do here is also to walk you through the kind of concepts of when you do a threat model and when you do an analysis, what are the kind of things that you want to look for and how do you approach an analysis. So what I kind of want to do in this session is also walk you through it, how I do some thread models, which are very code focused, which are very sort of focused on trying to get the maximum understanding of how it works in a very short period of time, and kind of the rabbit holes that I'll go into when I'm looking for certain questions. So again, please feel free to ask questions, interrupt as we go along, and point me, or if you spot any kind of security vulnerabilities or things that we should be looking at, absolutely, please, do that. So just to see this in action, what I'm going to do is I'm going to create a user. I'm going to come here, create a nice user. I can pick up different types of users. So actually, I can make a normal user in this case, and I'm going to log out. So the user that for you is OSS, and then the password is OSS 2020, right? That you guys can log in. So I'm just going to go here. So the gist of this, and I believe I put the link in the main site, but if not, where's the link? Oh, to the file, oh, some files, cool. So if not, let me just quickly add this link. So if you want some files to play with, let me kind of show you the engine working so you get a sense of what we do. So I'm going to download this JPEG, which is basically, this file. You guys can see that file, right? So basically a nice JPEG. And then, I'm going to download a JavaScript file, and I'm going to download a macro, which actually I'm not going to run because I don't have Office here, but you get to see in a second. So so this file has some JavaScript on it. So if you look here, when I go into the file, it has some JavaScript, and if I'm not wrong, and then we can also open up with Adobe Acrobat. So you can see that it will execute some JavaScript, which is the kind of stuff that we kind of don't want to see, right, on files. We don't want to see, JavaScript being executed in PDF, so clearly a danger. And what I'm going to do is I'm going to upload. So I'm logged in as A. No, okay, here I'm logged in as A, and I'm going to upload these two files. So you can just drag and drop it there if you want. So there's my JavaScript being processed, and now this version is actually running Docker. So I'll show a different version. In fact, I'll show you here. This is running the cloud. So at least we get both elements of it, right? So they're both doing the same thing. They're both processing the files, and what they do is they're both completed. So what they do is they the engine detects that you had JavaScript and rebuilds the file. So what the work that the engine does is it finds out the stuff that was there that shouldn't be there, right? And then literally rebuilds the file by removing some things like, for example, JavaScript, and cleaning up a lot of other things that should be fixed, basically don't match according to the standard. So you can see in this case, there's a length value in this that actually consistent with the value. So basically, this is, what we're trying to do is to create the file in a safe way. So we take malicious files, for example, that JavaScript one, so the one with a macro. So take a file that has a macro, and then, we process that file. Oops, there you go. We process that file, right? That actually, gets removed. So in this case, actually you have a situation where the extension was also wrong, right? Actually, because it was, well, I think the Office tries to do this, right? But in reality, it's just the XLS, and the macros existed. So just to see the whole round trip, if I go to that PDF that you had there, and I download the sanitized file, and I upload the file to the engine again, you'll see that now the end result, the file is basically now clean, i.e. if I look at this file here, right, and I'll take a look at the report, what you'll see is now it doesn't have any of the other things. So the macros have been detected to be removed. So basically none of this is being detected, and there's nothing to clean. There's nothing to repair because this is the engine who's done the round trip of analysis. And just to see a little bit under the hoods, we now have a really cool feature where you can actually export this file into our intermediate representation. So you get a zip out of this, and inside the zip you get these CSL files, which is basically these kind of metadata files, and including the images. So if you look, for example, here, you see that I actually have inside this folder, I got a number of images, right? So these are the images that were extracted from the PDF, right? Which is pretty cool. So this is basically almost, you can imagine, this is a textual representation of the file. And in fact, for some of our clients, what they do is they take this and they pass it to a diode, so you can transfer data securely across different domains. And then on the other side, we actually take the same files and we rebuild it together, which is really cool. So any questions so far on the workflow and how it works? You can see the same thing. Yeah. So I guess my first question to you is, how many vulnerabilities have you picked up already on that demo? Anybody? All right, should I do it again? Should I do the workflow again? All right, let's do it again.
Feel free to unmute yourself.
Yeah, please unmute yourself, right? What was that, Greg? Oh wait, where's the chat window?
Just when you're creating a user, there's no restrictions on the password lengths or anything like that.
Yep, correct. That's one. And that's and that's the kind of stuff, like the thing that's very important. Like when you look at a system, it's very important to start to see all the kind of the security properties that you have into that system, right? So if I go into here, you can kind of see actually there, right? So I'm now logged in as a thing. Let me log out. Let me log in as an admin. I think that's I think you can use, oh yeah, OSS 2020 is a super admin, right? And basically, yeah, you can see that, so from my view, like not only I was able to create a very simple user, right? I was able to create a very sort of, small passwords. Well, and the other one is that, clearly the complexity of that password is not very big, right? So if I delete the user, so you can see I deleted the user. So now I can come here, I can add a user, AA, make him super admin or admin, right? And you can see that I use username A, password A, right? And then what's it called? The password is weak. Now, the way this kind of needs to work from a security point of view is that this at the moment are features of the application, right? So one of the things that's interesting, and I think we sometimes forget this in security, right? Is there's a lot of security vulnerabilities that we call security vulnerabilities that actually are features. So you can argue that at the moment, this application makes it really easy to log in, right? Because I can create very simple users and log in super quickly, right? From that point of view. Now, it has security implications, right? And I want to explore that a bit later, but it's a good example of a feature, right? That actually exists in here that, we need to address. And so yeah, so the question, it didn't take a password to add one. Yeah, that's a good, although that's, so the comment here from otherwise, it didn't take a password to add one, but I would argue that as an admin user, right? You usually can change passwords without knowing the password of the user, right? So that's,
it's like, what I mean is like the admin didn't have to confirm their password to actually add anyone. They could add as many users as they wanted over and over again without even having to think twice about, you know, whether it was actually the admin or someone else stepped in and, you know, was doing something on there. You know, there's no, you didn't have to put in a password to add a user.
Yeah, but normally admins don't have to, they don't need a password to change the password, right? You know what I mean? So, and actually, if you look here, I'm logged in as an admin. So the admin, in principle, right, doesn't have, it cannot change things. It's only when you are as a super user that you have that capability. See what I mean? So in principle, you know, the admin should, the super user should be able to change everybody's passwords, right? Now, the other thing that I would add here is at the moment, this app doesn't support 2FA, right? Which I would say these days, it's a absolutely mandatory requirement, right? For a lot of applications. And then there's another interesting one that, remember that I just created this user, right? The user A. So if I log out and then I log back in, right? And I go here, can you see something that shouldn't be happening? Should I be able to see these files?
Didn't you log out?
All right, I'll do it again. So I log out, right? So I log in with that account. I come in here, oops, list users, right? And I delete that user, right? So now, you know, you can see that, you know, if I come in here and I try to log in as that user, it doesn't exist, right? So now if I add a user, again, same passwords, and I go and log in, right? It works now. You see what happened?
Yes. Yeah, that's the new user. Shouldn't be able to see any history, right?
Yeah, correct. And this is a good example of sometimes blind spots that occur, right? When, you know, for example, you still leave connections behind from, you know, using, for example, the username as a key identifier. So, and the reason now this is so important is because when you want to do a threat model and when you do a photo analysis to this, and you want to actually start to look at particular patterns, it's very important to have some hooks. It's very important to have some things that you want to follow because you just experience either a really good behavior or you experience a behavior that you're really concerned about, right? So in this case, the one I'm concerned about is what is happening on the back end that is actually tying the username to the results from that user, which is something that is very dangerous to do. So cool. Now so I just want to, because tomorrow we're going to go more, I want to go more deep dive into this application and how it works and the flow. And we're going to come back a little bit later when we talk about the Docker stuff of this. But the one I wanted to talk to you guys today, and that's where Matt is here, is this cloud environment here, right? So what you've got here is that when you go to the site and you buy a token and you get basically something to use, you can consume our API through a bunch of different ways. And one of the ways you can consume it is through these endpoints, right? So these endpoints, and you know, this has a key that is rate limited. So if you look behind the scenes, what's happening is that these endpoints are actually calling a bunch of AWS API gateways. And I'll show you in a second how that works, right? So you can actually see, in this case, first we call the file detection to say what type, and then we get some information back to say what actually file type it is. And the engine does a really good job at, really going deep into the file structure to understand what file type it is. And then you actually get the report, which is the analysis, which is then the one that was used to perform that analysis, right? So that's the one that you see here in detail when he's not clean, when he has some stuff to show. And then, that's the data that gets shown here. There you go, right? So you can see that's the stuff that got removed. And by the way, if I click on the new JavaScript, you can see that the new PDF, there's no JavaScript compared to the original one that has the JavaScript. So you can see files that look exactly the same, but one has JavaScript, the other one doesn't. Now, the way this works behind the scenes, and we'll go into the hood here, is you can actually go to Glasswell Engineering. Here, we're trying to be as open as we can about the information. We're publishing all this stuff here. The important part is it's the kind of flow on AWS is that you basically make a request, you hit the Amazon API gateway, then you hit the Lambda. The Lambda actually runs our engine, so runs the engine in memory, and then returns back this this function, the response to the user, and then you get back the call, right? So that's kind of the flow here. And the problem that we have is that we found a bunch of challenges on this flow here that actually creates a number of interesting problems, even from a security point of view, that I want to go through on this, right, with you guys. And just to show you behind the scenes, this is the API gateway endpoint. So that's the endpoint for that's one of our QA environments. But basically, this is where you configure it. So basically, this API gateway takes a request, and then we basically is calling the API QA rebuild function, right? Which is basically a function that is actually, which I'll show in a second, which is a Lambda function that actually is processing the file. And let me just go here, right? And this version, is this version protected by the key? Probably should be, right? At least the live one is. That has so these versions, there you go. So we basically use the API gateway for this. I'm introducing a new authorization model, but for this one, what you get is we're protecting this from usage by using basically these API keys that then have where is the plans, usage plans, yeah. So then the usage plans depends on 50 requests per second, burst of 25. So you can basically manipulate, this. So this is actually quite cool, right? So you can see that, with this, you can actually pass multiple, types of limitations on rate limiting that you want to do. And this is actually something that you want to double check, right? So you want to see how far we can invoke it. And by the way, everybody, please, please hack away, right? So the logic here is that, we invite you all to break this application, find vulnerabilities, and let us know, if you spot anything interesting into this, right? Because we want to know the vulnerabilities, right? Instead of finding out the hard way. So what happens if you look at this workflow here is you hit the application, then that is going to hit the Lambda function. Oh, so that's the API gateway, sorry. And then this, I can show you here, is going to hit this Lambda function. And then this is the Lambda function that is actually being executed with, with the rebuild process. So this is the one that actually has, in a way, the Glasswell rebuild engine inside of it, which basically then there's the process and then sends back the new file when needed. Actually, do you have any? I think from the diagrams, right? That's kind of it, right? I think we have a couple more other diagrams here that shows the workflow.
Yeah, there's an architecture under rebuild on the side menu, rebuild.
Yeah, cool.
Architecture.
Yeah, cool. Yeah. So, and this is the thing. So when you start doing the threat model, like you kind of want to start here, right? So you sort of want to go, okay, explaining how it works, explain me the sequence of events. Okay, so I go and I make a post, then that hits the API rebuild Lambda, that then calls the rebuild SDK in memory. So yeah, so then there's a couple of calls, first file type detect, then analyze, then rebuild, then send the stuff back, right? And there's now some interesting variations on this where we could also take a URL and then what this is going to do is this is basically going to get a pre-signed S3 URL, and that's the one that you use to upload. So you basically are able to also pass in a request, say, hey, give me a pre-signed S3 URL so we can upload a larger file. Then you send the file, and then you basically send the pre-signed URL, which then there's the workflow, right? Which then goes to the input storage. So you can see you pass the URL, go to S3 for input, does the thing, and then puts it file in there, the storage, the output folder, and then sends it back. Cool. Any questions on this? Where's the chat window? Oops. Okay, so what I want us to think about now is if you go back into the kind of, so at this the session I did today, I kind of went to this deck in detail. So I kind of want to do it now, but it's all about, understanding the threat modeling and understand the threats of your system, and understanding, you want to get a good model for this. And then what the key one that I want us to think about, and this is kind of how I want to do threat modeling on this, is that we basically just going to follow strides on this, right? So the logic here is to look at each of these elements and start capturing what are the multiple areas that we need to be concerned from authentication, from integrity, non-repudiation, confidentiality, availability, and authorization into this system. And this is what I want you guys to be interactive with this, right? So I'm gonna put some of you on the spot here, right? Since some of you are part of the team, I can get you to answer some of this stuff, right? So if you think about this bit here, right, the spoofing, tampering, repudiation. Actually, I wonder if I can just how can I show this? I should have actually had this in a nice big way. All right, so if you look at this architecture, right, of the system, of how it flows, right? So the first question that you want to ask, right, is from a spoofing point of view, right, is who knows who each person is, right? So I can start with you, right? So from the API gateway, right? In fact, what would be good to add here is actually the keys, right? Because I don't think you got it here, the keys description, right? But so from a server point of view, how does the server know who is asking for the data?
It's the XAPI key header.
Yep. So we basically we use the key header, right, to basically authenticate the entity making the requests.
Correct. Yeah. Which links to a key which is in a usage plan, which then dictates what they can access and the rate.
Yeah. And how many, in a way, and also how many requests they have available, right?
Correct. Yeah.
So, and now, so here's an interesting question, right? How does the caller know that the server is correct? So if I was using, let's say, this endpoint here, right? Or, you know, one of the endpoints that we publish, right? How do you know that the endpoint is correct? So how does this guy knows about that one, right?
He only knows because it's provided in the email, but he doesn't know it's the genuine article.
Yeah, actually, so I was trying to figure out the way to annotate this, and I was thinking, actually, let's try this. If I take a screenshot of that, so this is the kind of stuff that this is the Genesis bit, right? We're still figuring out the best workflows to do this, right? And by the way, you know, my favorite, which we're still not ready to do it, is actually to do these with graphs, where you actually start to draw the graphs straight away, right? So cool. So if I have this, that's not what I wanted. Nah, I wanted a big one. No, wait. No, you can't create a new one. Nah. I need a blank page. All right. There you go. Sorry, this is not the cool. All right, there you go. So I need a white screen to do this stuff. Cool. There you go. Great. And then we can actually copy this and put it there. Cool. There you go. Right. So what we got here, right, is if you look at the application, can I do boxes on this thing? There you go. If you look at the app, right, that we got here, and we look at basically the multiple players. Actually, I think there's an online. I should have checked. I think there's an online thread modeling tool. I'm feeling a bit. I should have done this a bit better. So if you have the attacker here, right, and you got the user there, right? So this is the ones we don't trust, and this is cool. So this is the user or the attacker, right? And the attacker is basically hitting the server, right? And then this guy is basically connecting there. How at the moment, we use API keys for this one, and we use SSL for this one, right? So I guess my question is that good enough?
I'm gonna guess no, just because it's silent.
All right, but if it's no, why not?
No, I don't know why. It was a guess.
So I'll just move it here because I think it's easy. I'm going to find it easier just to do this here, right? So if you got a user here, right, an attacker here, right, and he's kind of hitting the server, and so this is our attacker, right, and he's hitting the server, which is basically over there, here, right? And then the attack is going over SSL. And so the first question is, we're going over SSL or the user, right? So the attacker / user, right? So because you got both ways, right? So we got the attacker, and this is the server, right? And so we kind of using SSL in here, right? So you got SSL in there, or TLS, sorry, these days, right? So we got TLS going on there. And so this is where, and this is actually something that it's really important from a security point of view, right? Because what you've got from a spoofing angle at the moment, right, is we actually have, the API key being passed, right? So you got API key being passed and TLS going over here, right? So that's SSL over there, right? Now, there's a lot of, we now need to be pragmatic about this, right? Because, we distribute the API keys to the attacker, So the user, sorry. So if the user loses the API key, in a way, it's like the user using his username and password. Now, we can argue that eventually we can add JWT tokens and a bunch of other stuff to this. But fundamentally, like, we trust the user to keep their keys in a secure way. Right? Oh, so the credential is OSS username and OSS 2020 for the password. Well, so and then the question becomes, do we trust TLS? Right? In fact, if I'm going to be correct, this is API gateway, and so do you, in your model, do you trust TLS?
Yes.
Which is basically SSL.
You got to make that assumption.
Right? And so if you look at this, right, if you, in that case, then it's okay, right? Because the thing about this model is that if I don't trust TLS, then as a user, right, you don't trust that you're talking to the right server. But if I trust the TLS, as long as I'm going to the domain that, for example, right, I trust, like that one, right, or another domains, the ones that we provide, then it's okay, right? So if I hit the API gateway, that it's an endpoint that I trust, and this is also why it's important that you, for example, your settings, accepting self-signed certs, right? So one question to ask here is that, are we using self-signed certs? Because if you're using self-signed certs, then all bets are off, right? Because anybody can be in the middle here. So in this case, right, what we're doing is we kind of going and we sort of asking the questions, who can trust who? And let me just copy this over here so that this is better, right? And yeah, so we basically ask the question, can I, as the gateway, can I know who the attacker is? I go, cool, I got my key, and as a user, can I know what server I'm talking to? And then you go, okay, that's kind of the same process. And then you can ask the question, all right, so what happens inside AWS, right? Can I trust when AWS sort of calls a Lambda function, right? Is there a way for the Lambda function to be spoofed, right? Is there a way that this actually is calling a different Lambda function? And then the Lambda function is actually going to use the API, the Glasswell engine. And, is there any way that could be true in something else? So again, in this case, and this is a big point from a threat modeling point of view. I always find that you don't add to your threat model every single possible risk that is possible. And this is a very big one, because you can argue that TLS configuration can be added to here. You can argue that, vulnerabilities with the TLS situation, all sorts of other things. But my view on this would be, if your current system doesn't have that threat today, and you're addressing that, as part of your process or build, and it's consistent with all your other systems, then you shouldn't pollute your threat model with that. Because you want to make sure that every ticket you create in your threat model is actually relevant and actionable, or something that you can accept. Cool. So now we get to the next one, which is tampering, right? So when we now go from a tampering point of view, right? So Petra, can I ask this one for you?
Yeah.
So one of the things that it's super important, right? When you look at this from a tampering point of view, is to understand every data point that is sent to the server. And sometimes what we do here when we do the thread model is we basically ask questions and we start to understand what are the areas in the code that when you do a pen test, right, you want to care about. And in fact, one of the questions that you then ask the team, and it's good that they are here, right, is when you look at the documentation, where can I find the inputs and the outputs of the application? I think they're here, right? So what I'm looking for is literally every input and output of the application. Actually, this is more for you, Matt, right? Where can I find that?
Sorry, could you repeat the question?
Yeah. So where do I find? So when my question to Petra is, you know, what's all the inputs? What, from a tampering point of view, right? What should we be looking for? And in a way, for her to be able to even start addressing that question, we need to see all the inputs that we take into the application.
So if you go to the GitHub repo, you can probably get to the Swagger page.
Cool. Well, where's the link?
Should be on the main. If you go back to the main site, it's probably one of the pages, but I can't quite remember.
Oh, it's on the store. Cool. And by the way, like this is super important, right? When you ask these questions, you really want the dev team to answer with is it here? With these kind of links, right? And that's what you're looking for. So you're looking for oh, there you go, file trusts. There you go, Seb. But do you know where I find that link?
Yeah, it's on the GitHub repo.
But how do I find the GitHub repo?
There should be a link in the product page.
I think there was. I think you guys took it out.
Okay, wasn't aware of that, but
yeah, I think. But it should also be here, right?
If you go to the FAQs, there's a link in the FAQs.
FAQ, GitHub, cool. That's, well, okay, not that one. And all right, I'll find it from here, right? Which one is it? Is the file rebuild, right? SDK. That one? I think this is the one, right?
The URL sent, it's named, because it's a GitHub page, it's named after the repo.
So put it in the chat.
API, right? Yeah.
SDK AWS.
Yeah, cool. There you go. And but this, so there's the Swagger, right? Cool. There you go. Right. But all these little things make a big difference, right? Because if you think about it, like when somebody's testing this and when you're pen testing or section to review, it's super important to have all these links connected, right? Super important to actually have these things in play. Right. Okay. So here so Petra, this is now what you want to look at, right? Which is the inputs of the application.
Yeah.
So now what you want to do from a testing point of view is put payloads on all of these things.
Okay. And that would still be under the tampering.
Yeah.
Because you're tampering with the requests.
Because this request right here is under your control that is sent to the server.
Cool.
Right. So the question is, how does the server handles all of this stuff? So basically the hypothesis that you want to ask is, what happens if you send bad data into this? In the server side.
We'd expect it to handle it gracefully, but who knows?
Do you have evidence for that?
No, we need a test for that.
So this is where also, you know, a really good answer would be for somebody to say, go and look over here for those tests. So this is where we want to be doing this in an evidence-based way, right? So the reason why we want to talk about security tests and the way we want to talk about validations is because we want to make sure that every time we ask a security question, we get an answer that is actually testable, and we get a test that can now be executed with every build to confirm that no behavior has changed.
Yeah.
And when you look at, and it's interesting because when you look at something like this, the other question you want to ask, right, is what is this used for, right? And by the way, like, it's already really cool that when you can actually see all the requests and Swagger file, like there's tons of sites that I've reviewed that don't have this, right? They don't actually have a really detailed Swagger file that actually contains a description of everything that is happening here on the server, right? So that gives you some good descriptions of what's going on there, right?
And I have found it is linked from the engineering documentation, but just
Sorry?
not very clearly. So I'll move it.
Where is it?
So
from here.
If you go rebuild errors, it's off the errors page.
Oh, off the errors page.
Because it's saying.
Oh yeah, the Swagger there. There you go.
Yeah.
It's just about.
There's also a run-in Postman link, I think, in the quick start.
Yeah, that was cool. I was looking at that one there, right? Although when I tried it, it didn't. Yeah, do the thing. Okay, cool. So, but this is look, when you get to this point, is very interesting, right? Because now you start to be able to ask the questions. Okay, so what do I do with this now? Every time I look at things like this, right, there's always a number of checklists that go in my head, which is always, okay, what kind of data are you getting from the user, right? From the attacker, because remember that the attacker controls everything, right? The attacker can modify all of this. You have no control over that, right? So when you look at this, right, what kind of areas of concern, right, you can think of that you feel that what happens if this gets abused?
I guess you'd be looking to try and trigger an error and see what detail it's giving you back from the errors would be one.
Yep, correct.
And trip it over.
I agree. And one of my favorite party tricks, right, on these things like this is every time you see a string, right, and it's actually good that Seb is here, right, because you work on this stuff, right? So Seb is one of the developers, right? So every time I see a string, my question is, what is this here in terms of a type? What do you expect to see here, right, on that URL?
Starting with HTTP.
Yeah. But if I ask you for a regex for this, what would it look like?
At the moment, there's not any strong checking against that. Those two URL fields there.
Yeah. So again, if I ask you for a regex of what you expect to see here, what would that look like? Roughly.
It would have to have a what do you call it? I forgot the name of it now. You'd have the HTTPS part.
Yeah.
Domain and the resource.
Mm-hmm.
You shouldn't need a port in it though.
Yeah. And it's basically, what you're looking at, 50 characters, 100 characters,
mm-hmm.
right? And what kind of characters you expecting to see? Letters, numbers, you actually expect to see the normal structure of an HTTP request, right?
Yeah.
Can you tell me what a string is?
Yeah, I guess it should be more specific, like a UTF-8 string, because I think that's what it's getting sent to the server as.
Yeah. So can you see my screen there? So strings, right? I thought it was a bit bigger than that. Let's say 1 gigabyte, right? So strings are a gigantic blob of data. In this case, up to 1 gigabyte of data. Although there's probably a limitation on how much you can send on AWS, right?
Yeah, that'll hit the 6 meg
okay.
limitation.
So at the moment, this could be at maximum be a 6 meg string. Correct?
Yeah.
So
minus the size of the rest of the request.
Yeah, okay, 5.9 megabytes. So, but can you see that from a security point of view, right? That should not be allowed to enter your system. Right?
No, it shouldn't.
And this is where also, when you look at the vulns that we have here, right, for this rebuild API, this is now a vuln that we have that you know that you're not validating, right, the input that you're receiving from these fields, right?
Yeah, that's right.
And this is where, you know, when I look at these things, it's also very important to be very pragmatic, right? Because especially when you start to look at the source code, because it's either you do it or you don't, right? So either you validate it or you don't validate it, right? And if you validate it, what are the rules that you're validating? And if you're validating on those rules, can we find blind spots in your thinking of those rules on your regex that you're applying? Because the other thing that is really important here, when you look at this particular situation, is that, and this is where it can get very dangerous. If I go into the architecture diagram, right, there you go, right? So if I go into here, so this model is this one here, right? So that's the URL that I'm passing here, correct?
Yeah.
So one of the things, so here's the interesting thing, right? Now, and actually, this is where you go back, right, to spoofing, right, and all this kind of stuff, right? Because so the expectation here, there's actually a flow that is missing from here, right? So you guys should have a flow here that also describes all the 3 sequences, which is you go and get the tickets, so you get URL, and then you go and you pass it in the URL. So the interesting question here is that we expect that to be sent to this input storage, correct?
Doesn't have to be. It can be a URL to a file. Doesn't have to be in like a S3 store or something.
Yeah, it's any valid GET request that leads to a file.
Yeah. But who's making, okay, but now who's making that request?
It's being made from the Lambda.
Yep. So basically what you're saying in this workflow is this guy here is going to go to an arbitrary server somewhere on the internet to get a file, right? Are you actually even checking that if it's an S3 file, or you're just checking if it gives you a file back?
Just if it gives a file back, just to get request on the URL.
So this literally is just going to go to an HTTP endpoint, right? And it's going to get for file, right? HTTP, get file, correct?
Yep.
So what happens, right, if I give you a URL that looks like this? What's going to happen?
Well, it won't point to a file, so probably throw an exception.
Well, that's just because, but we're still going to try to open it up, right?
Yeah.
So there was a tile of vulnerabilities in what's it called, in EC2 that are caused by this. Let me just get the URL for you. So do you know about this URL? Where is it? What is it called? Exploit. Ah, here we go. Do you guys know? So one of the things that's really, there you go. So what happens, right? If this was running inside EC2, right, and you had the same pattern, what would have happened if I send you this URL? As my pre-signed URL.
Yeah, that's pretty bad. You would download it.
You download the file, and then you try to process the file, but then you wouldn't be able to process the file, and then you would send the file back to the client, right?
As long as it rebuilds.
Well,
yeah.
no, because if you can't rebuild, right? Actually, do we allow to download the original one?
No.
Okay. So that's interesting, right? Because you can see that's, if you had wired that functionality in, right, you would allow the full round trip. Does that make sense?
Yeah, because you've only got GET request on that bucket. It remains on that bucket. If you could get to a file that we successfully processed, then it would try to put it in the output directory of which has been supplied, so they know where that is as well.
Yeah.
So if there's files that they can get to, then that would allow the round trip.
So here, so the vulnerability that we need to add to our system, right, is at the moment you allow the fetching of any file, so basically you're now making internal URL requests from this Lambda function.
Mm-hmm.
And this is a very common pattern that has been exploited in all sorts of different cases, especially on people that elevate their privilege, right? Because, you know, this is something that you should never allow unless on very, very controlled environments, right? So if you think about it, the brief here is that you want to call, right? Let me just get these guys side by side. Where's the architecture? So the logic here is that you expect to call an S3 bucket, correct?
It's just any GET request that resolves to a file. We don't expect S3. We don't provide the ability to create them. They need to create them themselves. It's just an example. Everything's set up to be, as an example, you could use S3, and there's a proviso that the most efficient way is from an S3 bucket in the same region.
Yep.
But what's being done right now is that it needs to resolve to a file, and the output needs to, be compatible with a put request.
Okay. So basically you're saying that we allow unrestricted GET requests to come out from our server, from a highly scalable environment, correct?
Yep.
Can anybody think of other abuse cases for this?
Yeah, denial of service.
To whom?
Whoever's on the end of the GET request.
Yeah, made by whom?
Or put request.
See the problem? So that's kind of not good, right? So this is a good example of basically tampering, right? So if you look here, what we're doing is we're tampering with the request. So this is basically could now be a victim, right? So this could be the URL of a specific target, right? And if I was trying to, as a malicious person, right? If I was trying to do a denial of service attack to somebody else, right? This can be a good example of a function that facilitates that.
So if we narrowed it down to only S3,
yep,
wouldn't we just be allowing them to? Wouldn't we then lose our reputation by DDoSing S3?
Well, first of all, if you do that, you just already dramatically reduce the attack surface, right?
Yeah.
Because you now, are calling S3s, right? And basically the reality is, AWS at that level, scales really nicely, right? So it's unlikely that you can even cause a dent, right? On this, because you're going to call the Lambda functions, right? And Lambda functions is basically going to make a GET request to a S3 bucket. And if he doesn't have permission, right? He doesn't have permission, right? Although the other thing that's interesting here is what happens if they send us, right, a request to a massive file.
It will time out within 29 seconds.
Yeah, is it 29 seconds the limitation?
Yep. Unless the Lambda carries on, which I don't think it does.
Well, if you time that,
only if the timeout of the Lambda is higher than the API gateway, I think.
Which we've got them in line, haven't we?
Yeah, by 30 seconds.
Yeah. But can you see that the interesting part here is now our Lambda function can be used to attack others, and the Lambda function is now doing things that we don't expect it to do.
Maybe an environment variable of like an allowed domain, maybe?
Yeah. Well, now, yes, you now start to think about whitelisting this, right? We start thinking about what is the kind of functionality that we want to allow to occur from the Lambda function. Because you know that you can't trust this URL that is coming from the server, from the attacker. So in fact, if you think about it, right, if you expect to see if you expect to see a pre-signed URL that looks like, what does it look like? So if you have a pre-signed URL, right? Just give me an example. Then what you want is to whitelist, this stuff, right? So what you want is to whitelist the components of the pre-signed URL, so that you then come on, surely one of these guys. Give me an example of a pre-signed URL. Trying to find one that you get to see what I mean. So I'm just looking for a URL of what it looks like.
Do you want me to send you one?
Yeah, put one on the chat there. And actually, here's one, right? Yeah. So look, if you look at this, right, even just this part here, right, we can already limit a number of stuff in here, right? So you can already, start to say, do I need to send the whole URL, or you're just going to send me a part of it if I want to prevent? Or your regex could be confirming that it actually matches this structure. Because you could see that the pre-signed URL is going to have a very specific signature, a very specific pattern for what it uses. Ironically, right, if you think about what we do as rebuilding known goods, right, you want to almost make sure that you transform the URL that you receive from the attacker here, right, from the Swagger page, you transform it into a known goods environment, right, to a known good URL, if you want to support that. So that's definitely an area that we need to take into account here, which is, we need to protect that URL that's being provided by the user, and we need to make sure that it's not sending us to a place that we're not comfortable with, right? And the same way here, but same way with the output, right? So, and actually that output URL, is that where we're going to put the file to?
Yeah.
Yeah. So again, we have to be careful, right? Where we, any kind of output stuff that we send from our environment. And not what's really powerful about this is that from a defense point of view, right? and this goes when we go back and start to look at about, what your ecosystem is, that these are the kind of exploits and vulnerabilities that you should be able to pick up. So if somebody's starting to tamper with this, any error here should be really kind of taken seriously, because you don't know who, those are the kind of things that is either a bug, right, or something really dodgy is happening. And now the other thing that you want to do here, right, is this is basically going to convert into an XML, right?
JSON.
But eventually will become XML, correct?
Oh yeah, on the server.
So one of the areas, again, from a fuzzing point of view, is you want to start putting bad data in here to see what is actually going to happen. So because the bottom line is that you can't trust any of this data. But also the problem, and Petra, you're going to hit this when you start to try to do automated checks, right? Is that if you don't start with this, you don't even go past the gate. Does that make sense? So from a fuzzing point of view, from exploiting point of view, right? Mm-hmm. This is actually what allows you to even make valid requests. Mm-hmm. Right? So there's no point of a very limited point, right, of trying to fuzz or send bad data that is not on this structure, because it will fail straight away. Well, in principle, it should fail straight away, right? Mm-hmm. So this is the kind of stuff that when you look at automating tools, you always have to customize them a little bit, right? Because you need to teach it that this is the normal request, so that the tools can then start putting bad data in here in turn to understand what happens on the server side.
I see, yes.
Because without this, right, you're not even playing. See what I mean? Mm-hmm. And that's super important, right? And now you got the same variations here. So now the good news is when we do the analysis, in principle, the patterns are going to be the same, right? So again, when you look at the code, you want to see the same validations. And that's kind of, and then the question you ask the developers, right, at this moment in time is, this is great, right? So you got 3 endpoints. Are these all the endpoints that exist on the server that can be invoked?
There's 2 others. No, sorry, 1 other, which is just the API/rebuild. API/health.
Cool. So that should be here too. And what does that do?
That's an endpoint that SRE used to just make sure the land is still available.
Yeah.
Just to alert them if for some reason the land goes down.
But you see, but that's part of the attack surface, right?
Yeah.
So if you look from a tampering point of view, we want to make sure we understand if that takes any data and what's the implications of that endpoint.
I mean, that endpoint should not just be locked down to only be accessed from wherever, I think it's Datadog, isn't it, that they use to.
Well, look, I actually think from a consumer of the API, it makes sense to have some of those endpoints, right? If I want to make sure that the application is still healthy, if I was consuming this programmatically, I can see that being useful, right?
Yeah.
So you see, but the thing that's very important, especially when you do the tampering element to this, right? And especially when you start to map the kind of all the bits that exists on the server side, is you want to make sure that you send bad data to everything that is exposed here, not just the public interfaces. And that's something that, again, when you do the pen test on top of the thread model, you start to find those things out, right? So cool. So then, any questions on this? All right, so this is actually quite simple because actually in this particular version, the application doesn't actually have a lot of stuff, right? Now, the other thing actually that we need to talk about, which is massive, is the file itself, right? Because what happens if I tamper with the file? So where does the file hits?
So I'm not. You're talking about the file being downloaded.
Yeah. So the file that so the user is going to provide a file, which is by definition is a blob of binary data, right?
Yeah.
So when you send that, who's going to process that file?
The Lambda.
Yeah, and then it's going to call the engine, right?
Yeah.
So I think that one of the biggest threats that we have here, and this is where we think about tampering, is what happens if I start to fuzz the file and send, literally lots of malformed files, which ironically, right, is one of the things that we're supposed to prevent against, right? So what happens if we now, in a way, from here, we are now attacking the engine itself, that guy, right? Because a malformed file is basically hitting the engine, correctly?
Yeah, the engine's running on the in the Lambda.
And in fact, I can argue that this is happening, right? So basically, correct me if I'm wrong, but for all things and purposes, the attacker has direct access to the engine to send data into, right? Which is I know this sounds a bit obvious, but which is basically the point of this. But the bottom line is that all this is doing is just a glorified proxy to that thing, right?
Yep.
Because the API gateway and the Lambda are not modifying, validating, doing anything to the file. And I know, I know in our case, this is what we want to do, but in practice, it's important to understand how much work is being done here. Because, for example, we can protect against the file name either there or there. We can protect against a number of things, but from a file point of view, we will pass the file directly to the engine. So now the question is, what happens if the file pops the engine? Yeah, so from a security point of view, what happens if the malicious file triggers? And remember, this is, if you think about it, okay, in this case, this is Glasswall engine, but there's lots of similar patterns out there where this is basically, for example, I done a lot in the past, and I found lots of problems in the past in basically this one, right? So this is a very common pattern, right? Where you use a process or a Lambda function to create, for example, a thumbnail, right? Which is basically like Image Magic or whatever other APIs they're using, right? They use that to basically process a file who then gets saved somewhere else. So the question is, what happens if you pop this engine here?
No files are saved to disk by the Lambda as done memory to memory. So you shouldn't. You send the thumbnails created on the Lambda.
Any other ideas of what can go wrong here?
So if the engine gets popped, does that mean we have a denial of service?
So there's two things that I would concern me here, right? From yeah, so you got crash,
I
right?
guess you've got potentially a buffer overflow, which is the the end game for this, because then you're in unmanaged memory within the lambda.
Yeah, bugger. Sorry. Yeah, so the buffer overflow, and again, the buffer overflow can actually give you two things, right? Can again crash the engine, right? But the most worrying one is this one here, right? Which is remote code execution. So what this is when you trigger a buffer overflow that allows you to run malicious code in here, inside this process. Right? So what it means that the attacker sends a file in that contains both the exploit, like what triggers the overflow, and then the code that gets executed. And this is how a lot of buffer overflows work. So now the question is, what's the implications of running malicious code here that we don't control?
Well, it can be disseminated again back to, so the files that should be clean will now possibly maybe contain a virus that could go to all our clients without them expecting it to be malicious.
Yep. But actually, we'll get to that in a second, right? Because at the moment we only have one file, right?
But if it's kept alive, if the function's kept alive, then potentially will be there for the next one.
Yes,
Yeah.
and that's where we're going to go next, right?
Mm-hmm.
So the first thing we can do, right, is we could compromise the current file, right?
Yeah.
Which will basically be a problem, right? So if you think about it, but this is where a vulnerability can be very problematic or crazy problematic, right? So if you look at it from, even information disclosure and elevator privilege, right? And we keep still on tampering, right? If we allow the sanitized file to go through, right? Because what we want to do, so our flow is basically, we take that and then we create a nice clean file, right? So our job is to create a nice clean file that basically is what we send to our customers, correct?
Mm-hmm.
So that's the flow, right? And and yes, the Glasswall engine or from there, but fundamentally the flow is this, right? So it goes from here, it hits there. Oops, I lost my line over there. Oops. It goes to the Lambda function, right? And then hits the Glasswall engine and then hits the clean file to the place. So what we don't want to see is basically the ability for a malicious file to hit that guy, right? So instead of, so if you think about the first exploit, one exploit that you can have is an exploit that once it triggers, it basically modifies the engine to say, let the file go through, or say it's like the force, right? This is not the file they're looking for, right? So basically the file is okay, and then the file goes to the client, right?
Yeah.
Which is basically, it's not good, right? So that's what I mean by the buffer overflow, because the buffer overflow means that we now have a bit of malicious code running inside this process here, right? So we have code that we don't trust that is now running inside that process. And then the question is, which is, a very, very important one, which is basically, can I make this guy transparent? Is this environment here, is it pristine? This is the Lambda environment, right? So this is what happens inside the Lambda. Is this environment clean the next time you call the Lambda function? Right?
Mm-hmm.
And we know the answer for that now, right?
It's not.
It's not, right? And I have to say, this is still something that there's a lot of individuals that use lambdas, right? That still don't take this into account. which is the fact that that bit of malicious code, right? When you make the next call, will still be there.
Mm-hmm.
Which is not good, right?
Yeah.
And that means that in this scenario, the attacker could actually be injecting payloads into even clean files that didn't have malware initially.
Yeah, that's a disaster.
Right? So you can see that, this is a good example of, in a way, we need to, now think about how can we detect this kind of stuff, right? And how can we countermeasure some of these, capabilities, right?
Yeah.
Okay, so basically, so you see that what we've done here is we basically start asking the questions, okay, if I tamper the data, how bad does it get? Right? And in this case, you see by tampering the data, we can even trigger a buffer overflow on this thing, right? Mm-hmm. So then, okay, so now we can look at repudiation, right? So repudiation is, can we claim that somebody doesn't do something? So this is one of the examples that in this case, most of it is pretty clean until this scenario where we might think the file is correct, but then, we don't know where it is. But also the other thing that is interesting here is that do we track the actual API key when we actually put it in the other place? I guess by design we don't, right? So we just put it on the other side. So we don't actually track the source of this. Yeah, but I think on this one is pretty benign. Now, okay, let's look at the next one, information disclosure. Can you guys spot some information disclosure problems with this? So think about this scenario here, right? So think about the scenario of where you have malicious code running in here. What could the attacker do?
Could there be a way that the attacker could see these files that were coming through and potentially get access to some confidential information?
Cool. So how could that happen?
If the file sets up, the engine to, if the file says that instead of sending the file back to the customer, it sends also a file to the attacker.
Correct. I agree with you. And how, so the question, so what you're saying, and actually this is cool. So actually we should be cleaning this thing up here, right? So what you're saying is instead of doing this, what happens if it does that?
Yeah.
Right?
It could still also send it to the customer so that the customer doesn't suspect.
Yeah, correct. But okay, in that case, you might send the clean one to the customer, right? So yeah, so in that case, yes. So in that scenario, what you're doing is you're sending the clean one, right, to the customer, but you're also sending the file back to that person, right?
Mm-hmm.
So now the question is this possible? What do you reckon, Seb? Would that be possible?
I haven't tried it myself, so I'm not sure, to be honest.
Well, but this is where, look, this is where you go in bits, right? And remember that the thing about security, right? What is also very important, right? Is to have defense in depth, right? So the question here is that if I am inside this engine and I control the code here, can I send a file to somewhere on the internet?
Yeah, if the mechanism, using probably the same mechanism that it goes to a customer, it can probably be tweaked to just go to the attacker as well.
Yeah, I was just thinking that the irony here with this model is that you have to allow this Lambda function to go to the internet. Correct?
Yes.
Because if you actually look at the pattern, and this is why it's important to just literally draw this, because basically what we're saying is that this is our current pattern, right? So the current pattern at the moment is that we go in here, right? And we go out to the internet, right? And again, you know, we download a file, right? So this is the file that we want to get. You know, that's the file to process, right? So we basically go out to the internet somewhere, right? You know, out there, right? Outside the Lambda function. So we already know that the server has the ability to make HTTP calls, right? Does that make sense?
Mm-hmm.
So we know that by design, this server here at the moment has to be able to do outbound traffic, this Lambda function, because we wanted to support going to the internet and downloading something else, right?
Mm-hmm.
And actually, if you look at this, the flow here is that this is AWS, right? So if you look at this workflow here, that other part here is AWS, right? So if you look in this situation, you've got AWS here, right? You send a file over, right? Okay, maybe correctly like that, right? So the file goes in there, right? With the API key and the payloads. And basically we know that the server has to be able to go to the internet, which basically means that if we trigger an exploit here, the server will be able to send the file back to anywhere the attacker wants it to go.
Is there a mitigation in terms of the fact that the engine is loaded and then unloaded on each request? It's not the same loaded into memory Glassful engine, or is once you've caused the overflow, obviously the overflow for the file that's being processed at the time, but you know it's not the same instance of the engine. It's unloaded and loaded back up.
You'll have, you know, so if you need to think about it, so in this case, the exploit code will have two components, right? We'll have the component that triggers the buffer overflow and gives you remote code execution, right? And then you kind of have what you do next. So, and this is the thing of the Lambda design that I really don't like, which is you can start all sorts of processes in Lambda that when the Lambda ends, it doesn't shut down those processes, it just suspends them. So that means that on the next request, all those processes will still be there. So in that case, even if you start the Lambda function, the Glassful engine every time, right? You can't control, right, what other process has been started by now. In fact, you can even change the source code of the Lambda function, I believe. Or maybe not. I think it depends where it gets written to. But you could basically have a process running that actually, I think you can modify it, because I remember reading about these guys who actually were modifying the actual Lambda loader from AWS. It's pretty insane, right? So yeah, so you can't trust it because so put it this way, even if you don't have a malicious thing there, you will have it here in the same space, in the same process space of the Lambda, and this process will have full access to everything that's running in here. So you can see that in this case, we can disclose information, right? By, the information disclosure will be that if the file can be leaked from here. And now this is an example of we have this risk because at the moment, it is possible to do this. If you then, so this is where it would be really interesting to compare this with the version that runs here, right? Which is basically Dockerized, where, you know, this thing here runs on Docker, which basically means that with every request, you have literally a new pristine version of that environment. Now, you still will have to address the question of whether, you know, you basically, you know, can go to the internet, which I would argue that, you know, we want to lock it down, but at least you get a pristine version. Where my worry about the Lambda functions is that to detonation files, we now have to be very careful in how it's done. And it might be a case that we might not, we cannot use hard starts the same way that you might want to use. You might think about it. See what I mean, Seb?
Yeah.
Because in one way, you kind of want the hot start because it gives you the ability to start a thing super fast. But on the other hand, right, you have a situation where it could pop the engine. And by the way, everybody, I think in this space has the same problem, right? It's something that we need to address, right? Because we want to address malicious files here. And then now if you look at the next one, denial of service, is that what happens? So an interesting question here, right, is what happens is when the engine crashes, right? Or if you can crash the engine in a way that it doesn't start the next time. So can you denial of service? In fact, I've seen cases in Lambda functions where you can leave the Lambda function in a state where it starts, but it doesn't function correctly. A good example is, because you know that the Lambda functions only has 512 megabytes of memory, so disk space. What happens when you fill that up? Any idea?
I'm not sure.
So those are the kind of tests. And this is where, you know, Petra, when you look at it from a security point of view, some of these things, we need to game the system, right? So that means that we need to create a Lambda function that you control, that you can manipulate, that you can ask those hypotheses. Mm-hmm. Right? Now you can say, okay, now I'm going to run this with 500 megabytes of memory already, or disk already used, or 3 gigabytes of memory already used, and then see what happens. Because I actually think that when the memory runs out, it crashes, but when the disk runs out, it doesn't. But you might have a problem that your Lambda can still always start, right? But it would always fail because there's not enough disk space in that hot Lambda. Mm-hmm. So these are the kind of tests that we want to do. But what I want is, I want us to validate this, right? And it can be something that you do with a couple of tests and then, you know, try once, right? Or validate once. Even, you know, it's actually, you want to make sure you leave a test behind that confirms that check. So we understand the limitations. And more importantly, we can look at how to detect these things. Because, for example, if we're paying attention, an outbound request from the Glasswall engine to somewhere on the internet that is not a particular file is pretty weird. So we should be picking up some of those things. Or at least in a particular sequence of events, we don't expect an outbound request to occur at that moment in time, or at least maybe 2, right? If this is what happens. So this takes into, for me, a big question, which is, you know, you're always going to have some vulnerabilities and risks on systems like this. The question is, are we detecting? Are we monitoring? Are we actually validating all this stuff? And then the final one is elevation of privilege, is the authorization of this stuff. Are we actually, is the attacker able to do things that he's not supposed to do, right? Or access data that is not supposed to access. So in this case, it's pretty simple, I think. There's not a lot of places. I think the main one is if the attacker can modify other files, i.e., do things in there. Or actually, so here's the other question, right? What is the key that is inside that Lambda function? So one thing that you need to look at is when you look at the, so from a Lambda function point of view, you always have to ask the question, what happens if the Lambda function is compromised? What happens if the attacker is inside the Lambda function? So for example, Seb, you need to look at the privileges that you give to this Lambda function. And every privilege at that moment in time really matters.
Yeah.
Because, for example, it means that if you normally write to an S3 bucket internally, right? Or if you have the ability to talk to other systems in AWS, all of those capabilities could then be abused by the attacker now. Does that make sense?
Yeah, it makes sense.
So what you need to think about is you need to assume that the key that you actually use to run the Lambda function is actually, the API role that you gave the Lambda function, should only have the exact functionality required to perform some of the actions. Which is why, for example, even some of the modes that we have might actually have different keys and different modes, because you want to lock it down to the maximum, to actually the minimum of required privileges that you do there.
Just a quick question, Dinis. I'm just sort of thinking to something I've read recently around cross-domain systems. So, and one of the things that quite often it's done there is kind of tracking through some of the credentials you're passing through to actually validate at the end to kind of deal with some of these issues to make sure nothing's been corrupted halfway through. Is that the kind of thing we could potentially implement here?
Yeah, so I think one interesting pattern, right, is, for example, like when we store the clean function, the clean file here, is to also store the token that, or at least a hash or something that allows us to connect back to the original person who did it, and store that kind of metadata across the system. And then if you have multiple steps, so one of the nice things of the JWT token is that you actually can allow, for example, this engine or this Lambda function or the Lambda, the process downstream to validate if it's still a valid request. Because at the moment, if you think about it, right, the other blind spot here is that the Lambda function doesn't authenticate the user, right? It's the API gateway who does it. So by the time you hit the Lambda function, this thing will process any file that's been asked for it. Right?
Yeah.
But so Greg, I think one of the things that is also very powerful here is to start to capture all sorts of metrics of what happens across each system, and to be able to visualize it and see them, because the irony is that you absolutely want and use that all over the place for your QA testing and your quality assurance, and everything is fine, but it also gives us lots of early warning signs if something has been compromised. And that's one of the big defense, fundamentally, that's the only thing we have against an attacker, right? Is the fact that, we should know what our systems look like, right? And we should know what it behaves like, and we should know what are weird activities that don't make sense, right? In the normal behavior of our application. So that means that, some weird engine crashes, some weird stuff going on, we should be paying crazy attention, because the bottom line is that we're processing malicious files, right? And we should be able to, for some of these files, we should be very aggressive when something kind of goes wrong. And not just going, oh, the engine crashed a couple of times. It's very important that we follow those things up, because one of those crashes could be an exploit, right? It could be somebody triggering a payload. Or it could be somebody exploring a payload, right? Now, the interesting thing about, for example, from a defense point of view, right? And this is where the models can be interesting, is that if we save the file, we can go back in time, right? So if you look at, for example, the model that happens on the, what's it called, on the server, where, the forensic workbench, one of the things I really like about it is the fact that it, if you look at this file, this structure, right, this is really cool, because for every analysis, right, you then have basically you got this structure where you got the config file that got used, the inputs, the outputs, the kind of metadata of the analysis, a bit of the raw analysis, and then the report, right? So what this allows you to do is, imagine here, in fact, one of the things I want to have here is also add the hash of the file and start to add some more information that we can collect from the file. And then, if we ever got exploited, right? Or if you start to have weird stuff going on if we have access to these files, we will see what the attacker did. And this is where now it gets interesting, because from an attacker point of view, right? If you have an exploit, that is kind of like the difference between a missile, right? And sometimes a digital payload is the physical missile. It gets destroyed when it gets to the other end, right? So you're attacking somebody, but you're not leaving them with basically your prize technology and the stuff that you develop. Where if the attacker sends a file and we keep the file, then we will be able to reverse engineer, and we'll be able to figure out the root cause, and we'll be able to actually make it stop working. But if you don't keep the file, you can be exploited and never know what happened. So this is a good example of a risk, that you will have a risk either way. You have a risk if you keep the files, and you have a risk if you don't keep the files, which is also quite common in security, that some of the decisions are not binary, right? Cool. So can you see how just by asking these 6 questions, right, on here, we can get a lot of mileage, right, from, just even simple data flow diagrams, right? And there's a better tool, I remember, I think there's a tool that allows you to do this programmatic. I'll dig it out. And also, I think there's a couple of UIs that allow you to draw this the same way I was drawing now. But I think it's very important that we also go by pattern, because or else it gets quite convoluted, right? So if you, like you see here, like when I was trying to, execute multiple patterns, it becomes quite hard to do that. So what was that? Striped. What's that?
It's there's stride and striped. Striped is the stride with the addition of privacy, I think it was. It's been a while.
Oh, privacy. Oh, I like that. Yeah. Striped. Yeah, actually, that's quite good. Yeah. Yeah. So you need to start to consider the privacy implications, which is kind of information disclosure, right? But you're right. Privacy has an extra element to it. I like that. Striped. Cool. Yeah, because from a privacy point of view, right? Yeah. So this one has, well, you has information disclosure, which might affect some users, right? And also this is also why it's important. So if you look at, the reason why, on the store, we went with the idea of, providing, if you look at this model, providing a dedicated rebuild API versus the cloud one, is because on this one, if this happens, right, you now have a user accessing malicious files accessing files that don't belong to that user. Where in here, right, it's all the files belong to the users calling, that environment. So it's a much more solid sort of solution for that, because everything kind of stays there. So it's a good example of, understand the limitations of what we do, so that we don't oversell, this thing here. But I want us to explore the idea of actually either having cold start lambdas or really have a way to clean up the lambdas, or explore the way to use the lambdas to trigger, right, a pod starting somewhere, right?
Could another way, Dennis, which could be something that actually detects whether it's been tampered with.
Yeah. I agree. Yeah. So that I think that's something that would be good to do some research on, which is, okay, so you have malicious code execution in a Lambda. How far can you hide, and how far can we lock down the Lambda to make sure that the worst case scenario is that one request? Because my worry with this is that we go from one request to multiple requests, which is what happened with this. If you remember the Heartbleed, vulnerability. Not that one. If you guys remember this vulnerability, right? The problem with this, right, is that it basically allows you to see the memory, right, of allow to see the memory of other requests, and that was really nasty. So what happens if you have some email and some stuff, or some things you can invoke, right, or your endpoints, right? You can then start to see the memory of other requests, which is basically a variation of this, right? So you got an attacker not just compromising his file, which in our case would be bad enough, but compromise every other file that goes to the system, or sees every other file that goes to the system. And to give you a variation of this, right? And this is where you have to take into account that, okay, so here's the question, right? If the attacker is not able to do this, right? So if the attacker is not able to send the file back to it, but he can still do remote code execution, how would the attacker get the files out? So the game here, right, is the attacker, right, is not able to do this, right? So the attacker can send multiple requests. He can basically, compromise the server, right? But how can the attacker still get access or still download the files being compromised? Any ideas? Because remember that we still allow this to happen, right? Actually. Right? Because we still allow this to happen, right? So we still allow the attacker to receive his clean file, right? Actually, in this case, we can send the clean file directly to him, can't we? Because you allow the S3 bucket to be anywhere on the internet, right? So we actually allow this, or variation of this, right?
Yeah, that's right.
Right. So we allow and okay, he then sends the. So the exploit I'm thinking here, right, is a variation which these guys once told me this story of a credit card, a buffer overflow on the credit card payment. So what happened, which is pretty spectacular, is they had 2 credit cards. So imagine you go to a shop, right, Starbucks, right, or Nando's or whatever, right, and the first credit card that you put in to pay triggers a buffer overflow on the reader. So they put the payload on the microchip, right? So it triggered a buffer overflow on the reader that put a bit of remote code execution running on that reader, right? The card reader. And then what that did was recorded every card used, from there on. And then what they did at the end of the day, right, or a couple of days, they'll come back with another card and they would trigger the same buffer overflow. But in that case, the code was designed to go and download all the data that was there from the previous payments into the card. So now they got the card with all the credit card details. Pretty cool exploit, isn't it?
They did that with a voting machine as well.
Oh, is that where the voting machine happened at the same time? But why would they want to get the data out? That was just to tamper with the data, right? On the voting machine.
Yeah, it was to tamper with the data. They didn't need to. I'm trying to remember how they did it. It was on a documentary actually about it, but they basically did the same thing. They had these cards that they put in, and somehow, I think they triggered the buffer overflow, and then they were getting I think they were able to trigger it so that they could change it by just the one bit. I don't recall exactly how it worked though, but it was basically remote execution.
Yeah. And then, so when you got that, then you can start to modify the votes thereafter, right? And randomize it a little bit so it doesn't completely, go for your candidate, right? But you just shift it by 10 or 20%, and that's enough, isn't it? So I think that, just wrapping up, so the attack I'm thinking here is that there's a two-stage attack. The first one, you trigger buffer overflow, and you start to execute in memory. From that moment on, you start to record and capture every file sent, and then you make another request. And then what that does is that puts all those files in a clean file that is then sent back to you. So that would be a way to, again, access data. Well, it's a mixture of information disclosure and elevation of privilege, because you're basically, you're doing things they're not supposed to be doing, right? So the key point here is that, we're handling malicious content here, right? Is that we really need to make it, very sort of, consider that, this could be completely compromised. And actually, the other thing that we need to really think about is we need to allow encrypted zips to be provided with the file payload. Because at the moment, we're actually forcing the user to handle malicious files directly, which is not good at all. Right? So one of the things that we should do from a usability point of view, if you think about it, at the moment, we're forcing the user that maybe is trying to play around with some malware or exploring or even, trying to process the file, he literally will have to click on the file and drag and drop it or send it to us, or maybe programmatic not, right? But we should allow encrypted files to be sent over that we decrypt and then process and then send it back. Just another interesting thing to add. Cool. It's about wrapping up. Any final questions? I hope this was sort of useful from a kind of how to think about this and how to do a threat modeling on these sort of detonation chambers inside Lambda functions.
Yeah, it's interesting.
This was great, Dinis. Thank you. Really cool.
And the format is always the same, right? And it gets more interesting when you can look at the source code. So for example, like when we were looking at something like this, the first thing I want to do is show me the source code of that. Because immediately you start to understand the scope of the problem, and how, and also, Petra, like in some of these cases, you don't have to fully understand the source code. You just have to ask the question, show me how it works, show me what you're doing, right? Show me the validation, because you can see that in the source code, right? A code that doesn't validate anything is literally a GET request, right? A code that validates stuff will have more meat on it, right? So, those things you don't even, you can even do, I can do it in a language I never heard before, but the patterns are going to be equivalent. Sweet.
That's great. Yeah. Thank you.
All right. Let me stop. I'm going to stop the share. Stop the recording. Oops, nope.